start recording. We are recording now, and what we are about to do, oh, we were about to make this function here.
But what are we doing today?
Yeah, today would be the day of Spoon, but because we're gonna wait for Mageta, we will just do
Well,
knife today and postpone it
d-
to Sunday, the other one.
you are parsing, right?
Yeah. So
What is?
this and this. And maybe it is a touch too small. Now it's okay. To Boolean. And as far as I remember, this is already being used here. String to Boolean. Let's see. Unknown form in line
Oh,
57. Oh, this, of course. Nice. Um, main. There we go.
nice. Hmm. Hey man, go to the main file, like knife.
Here.
So yeah, the thing that I was talking, uh, like you remember where we were doing like the identifier part, and we were dealing with white spaces and shit.
Yeah. Oh, we could do this today, by the way. The many star parser, like the 0 or more. We could do
Mhm.
this today.
Yeah, but the thing is, uh, like, okay, going from the beginning,
Mm-hmm.
what do you think of us writing some sample of the thing? Because
I think I already have
especially,
that here.
yeah, but that doesn't.
And we have the... Oh,
uh,
no, wait. This is not... Okay, so the mode... Oh, I am in knife, not in spoon. Okay, so we don't have the editor stuff here that Mageta made, but it's already working at the bottom here, like the
you
highlighting
mean,
and the spoon icon at the bottom.
yeah, but I mean, we need. Okay, it could be more than a sample, but in the sense that we need something that describe our syntax, man. Because otherwise, it would be a
Oh, you're talking
pain
about the
in the
grammar.
ass. So, yeah.
Uh,
So
yeah,
we
we
can
can
do it
have that.
freestyle. We don't need to follow any
Yeah,
specific way to describe it.
we can have that, I guess.
Yeah, I'm thinking about that because how can I say
Yeah, so this is
a way
something.
to describe it?
Yeah, but let's make our own way because I think we are kind
No,
of
yeah.
biased when using someone else's.
Well, yeah, freestyle. We can just do freestyle.
Okay, so let's create a folder here called
I think we
uh,
only need a file, really.
just a
Like,
file, you mean?
yeah, it's not big.
Okay, so where this file would go?
Not
Randomly?
a clue.
Okay, so grammar.
Could be anywhere for now, right?
Hey, grammar.
Okay.
Okay,
Yeah, you
so
could use like Markdown or the other one that you like.
oh, org. That's cool.
Yeah.
So let's do add org here.
Uh, okay, so the first thing is we could like start simpler if you like. For instance, yeah, it looks really cool on your stuff, but is GitHub already like rendering like properly those stuffs or?
Yeah, it's already ran. It's already like applying some styling, let's say.
Okay, that's enough. So yeah, we could do two things, Lemos. You probably would prefer the simple one, right?
Yeah.
So the simpler one would be, okay, let's define what an expression is, and then the file is just an expression, and it can have white space before, white space after, right? So
A file is not an expression, right? As far as I remember.
it depends on what you mean.
A file is a set of functions, I would say.
Yeah, that's why that's the simpler version
Oh.
because I could describe it as a list of top level declarations. And then they could be either an expression that basically the result is ignored,
Yeah.
only the side effects will take something. And well, they could be type declarations, right?
Yeah.
They could be function declarations.
Oh yeah.
So yeah. So what about doing an expression for now?
Yeah, expression's fine. Expression's fine.
Okay.
Specifically S expressions. What do you think?
Uh, yeah, that's the thing. Can you? I'm not sure what is an X expression like. Can we take a look on Wikipedia to be sure?
I think that we defined this a long time ago. So an S expression is an expression. Uh, uh, it's kind of like this. Uh,
Yeah, that's not separator that you mean, right? That's
I don't know
enclosed.
the limiter. I don't know the name.
Uh,
I don't know names.
yeah, but okay. But that's fine. But yeah, the thing that I was thinking about is okay. What about a atom? Uh, is that an S expression?
No,
No,
no.
then we are not having S expressions because atoms are expressions, right? So you could at the top level write only like one, right? And well, that would be valid.
Oh no, but that's only the case because we are defining a file as an expression. In this case, yes, the number would be an expression.
Yeah, and then I'm saying, oh, then we are defining a file as an expression, not a as a S expression. If you say the atom is not an S expression, for instance.
Yeah, okay, that's the case, yes. But how we are representing that in our thing? Because this
Um,
grammar needs to consider both parts, the parsing and the ST.
Huh? No. Grammar is like syntax only. You don't
Oh no, but in our ST we are already handling that, I guess.
handling what?
Yeah, maybe it's easier to explain what I want to explain opening spoon. So evaluator. Yeah, so I mean that whatever we define, we need to take into consideration this. That's what I mean.
Uh, yeah, Lemos. Okay.
What
So
type
the
of
things you are,
expressions we are ready to receive? That's the question, I guess. And a
yeah,
number is here, so you're right.
but the thing is, Lemos, we are defining the grammar, so we can parse that like strings. But you see that that doesn't define what kind of AST we will spit, like when parsing those strings.
No, that doesn't define by itself, but we kind of did in reverse because spoon is more advanced than the parser.
Okay, what I mean is, redefining the grammar has like little to do with the EST itself.
I don't know, man. I don't know if that's wait.
Okay, I'm talking in the sense that when defining the grammar, you are not thinking about the specifics of your nodes on your AST. You only need to know that you have information enough to not be ambiguous, to have all the information to generate the nodes, but you are not thinking the sense of, oh, it needs to be in that way because it needs to generate the node, because they don't relate as much. Like you could parse any string and spit the node that you want if they have the enough information, I guess.
No. I'm saying that, for instance, when we are defining the grammar for an application, I don't think it makes sense to try to like create an AST that runs away of this. Like an application needs to have this structure, this pattern, I would say, because this is the pattern that we are expecting at the end. So yeah, we can pick a string and parse whatever AST you want. That's
Oh,
fair.
yeah. In the sense that you need like a kind of like one to one or one to, yeah, like for each thing on your ST, you need at least one, right? In the parsing.
Yeah,
In this sense,
they need
yes.
to be connected somehow. And the way that what I'm saying is that okay, let's think about the possible, for instance, application. Let's go to application of expressions, right? Which type of expressions we can have in our grammar? You would say.
Yeah. So yeah, the first thing is, like you said for us not to use that notation in specific, but we need to use, or at least would be really good for use some like ad hoc variation of that. Because if you are describing things with list and such, that's a lot more hard and work for sure. Uh,
Well, you can propose whatever notation you want. I just made
yeah.
one ad hoc here. Like,
But
I'm not
okay,
saying it's the
so
best way of
we
doing it.
can like just say expression, right, is equal to, and let's list the possibilities of
Yeah,
what an expression is.
yeah.
So it's either number literal, right?
Yes. So, um, mm, that's. I think we need to define literal first.
No, 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 you don't. You don't. You don't.
This can be just for now, just for my mind at least, boolean. And here we have a literal.
Oh, yeah, 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 that helps a lot. I thought you were defining like something regarding specifics of how our integer literal is composed.
No, no.
Yeah. Mm,
What an expression can be, it can be a literal. That's fine. I also think it can be an application.
yes.
So now it comes the. We can talk about this later. What else? I think we also have an abstraction there,
Abstraction. Yes.
and we also have variable and condition.
Yeah, wait a second for the variable.
No, I'm just listing. We can evaluate now.
Oh, okay. Yeah, then the condition, right?
Yeah, the condition.
I think that's it for now, right?
Yeah, we need to discuss if the variable makes sense or not.
No, yeah, it can make sense. And
Okay.
the way it makes sense is, well, it can make sense. Uh, so variable could be equals to identifier, and that's the case because we need to use the identifier inside abstraction, like they are the same, right?
Mm,
So let's describe, for instance. Oh, wait. Oh.
identifier. I think this needs to be space. Actually,
No, no,
no.
no, 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 no,
White
no,
space.
no, no. It doesn't need to have any white space whatsoever.
Yeah, that's why I'm putting the star.
No, no. What I mean is on the parsing, we don't even need to worry about that.
No, but we will.
But that is no reason why, because you are doing in other places already.
I am I? Are you sure?
Well, you will.
I think that right now I'm kind of assuming that after a delimiter, I'm gonna have an identifier, for instance, to make the arithmetic and the boolean ones.
Yeah, but the thing is, for instance, let's suppose the only thing you have in all your file is a variable, right? Is identifier. So why don't that need to be specified in the identifier part of the grammar? That's why we are already expecting white spaces, expression, white space. In this case, the expression is the identifier, so it doesn't need to handle the white space again. In the case of the abstraction, that we do expect the identifier to be somewhere, the abstraction is an S expression, and he's already handling those white spaces that could be in
Okay, can you
places.
repeat again, just for me
Yeah.
to see if I understood why you think we don't need to add this here?
Yes.
Okay,
So, okay, let's suppose the cases in which identifiers appear, right? There are basically two cases as of now, I guess.
okay, that's
Uh,
fine.
in the case of the thing being a variable, right?
Mm-hmm.
So let's think about a file that only have a variable. Of course, the file can have like white spaces before and after, right?
Yeah.
But why don't we need to care about those white spaces in the identifier grammar part? That's why we already describing the high level as being, oh, maybe white space before, maybe white space after, and an expression in the middle. So the
Oh,
expression part is already
all the
handling the
expressions
white
are
space.
already considering that.
Yeah, like the
Oh,
other way it could show up is in the abstraction, and the abstraction is an S expression. In this expression, we already handle the white space. They are like his separators, right?
Oh, here. White space star. And here also.
No, wait, that's not quite right. That's not quite right.
Why?
In the sense that you are doing for S expression, not for expression. That not the same.
No, but this is already be. This is what I understood what you said. The outsider parser, like the one that is not, that is considering the expression to be an atom, is like an atomic, not atom in the way that you're talking, like only in the description of the grammar I'm talking. So this is already being discarded. So we don't have to tackle this anymore. We can
No,
just
no,
keep
yeah,
this.
it's okay. You put there like between the delimiters. But well, it's technically wrong because you are not describing a list, right? You're describing only like an expression enclosed in delimiters. So we need to
Oh,
describe a
so
list.
maybe adding white space up here.
Oh fuck, man,
and
the
and
thing's
then and then removing from here.
well. First of all, yeah, you do need to remove from there. Like you need put before and after the expression in the
Okay.
expression and not the S expression. But the white space there between the delimiter and the expression is
Uh, I'm
okay
not getting why we need this in this section. It seems weird. Why not
because
here?
yeah. So we do need in both levels.
Oh, we do. Why?
Because yeah, because the file is only an expression for now, right?
Yeah.
So for now at least, we need the file to accept white spaces, like before and after. It
Oh,
happens, right?
okay, okay. It happens that in the expression is inside an x expression, s expression. Okay. I don't know how I'm gonna add this information here though.
Okay, you can describe a file.
Oh, here. I need to put in here, I guess.
No, you can put literally like a file is white spaces before, white space after, and an expression in the middle.
Okay.
And
Okay.
later you can change what a file is, right?
Yeah.
Without changing what an expression
Okay. So
is.
file.
But that's the thing. Why don't you use the same tree? Because you need to use those names, like
Why I don't use what? Sorry.
the same quote unquote tree that you are using for expression. Because they can be all one tree because you need to use all the names. Like
I'm confused of your suggestion, man.
okay, so you see this bunch of like lists that you have there, like literal, identifier, application,
Yeah.
abstraction,
Yeah.
condition. Yeah. So let's call this a tree, right? We
Okay.
are like describing our
Yeah. This is a tree.
like
This is a tree.
concrete syntax tree.
Yeah.
So yeah, the thing is, we are going to add file on describing our grammar, right? But file will refer to expression. Do you agree?
Like this.
Right? Yeah. So I don't think it makes sense we separate in sections. It's only one section because they all need to refer to each other.
Ah, but that's gonna be very, very like back and forth. That's why I want to do it like this.
Back and forth.
Yeah.
What do you mean?
So, oh, we have a file here. Oh, a file is an expression, and an expression is here. Oh, it can be a literal. A literal is up there. You need to go.
But that's how it works. Like it's a tree. That is like
Yeah, but I kind of want to decouple them a little bit. For
But
instance,
man,
the
take
S
a look.
expression is here. But I think, oh, I just want to talk about S expressions. What matters for it? Oh, only
Yeah,
this.
yeah, but take a look, Lemos. As expression is referring to expression. Expression will refer to as expression, so will be the same up and down, but in different sections. That even worse.
No, I don't think it's worse because
Huh.
you at least have a core idea of what this section is talking about.
But that's why we have a name there, like calling literal, identifier, application, abstraction.
Well, we can make it like this. I think it's worse, but well, we can do your way. That's fine for me. Uh, Delimiter. It's this or this.
Yeah, that will generate a wrong grammar for us. See, because then a valid thing it could be described by left bracket, right?
Uh,
Let me write in the chat.
Oh, you need to separate those.
Yeah.
Okay, so let's call this the O, and this is the
Oh.
C. Yeah, C for opening. O
Why,
for
why
opening.
not left and right?
Left and right. Can be that. I kind of don't like it, but that's fine. Uh, yeah, but you're correct. That
Oh,
would,
okay.
in fact, add
Oh,
create
wait,
a
wait.
clean grammar.
Yeah, but that is the thing. Also, I think we will be like huge verbose that way. Um, so take a look. You know that we can describe some things as a literal, right? For instance, if you go on condition, you agree that on condition we need to literally specify a string there, right?
Yeah,
In the sense that it
yeah.
needs to be
Mm-hmm.
if, and it
Yeah,
will
yeah. I'm
describe a
just not
literal.
doing this with the delimiters because we may change our minds to this.
Yeah, that's true in the sense of abstraction. But yeah, it will just be verbose, but not a real problem. Okay, so variable, we already have it, like it's literally just the identifier. Uh, the next one that we have is application, right? So, oh yeah, we have file. Okay, yeah, plus, 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 plus. What about changing the plus by just space?
I kind of prefer having a symbol to like mimic the glue.
Yeah, but why don't we use the plus to describe one or more? Because that's something that we will need.
That's a good. That's a good suggestion. So using the plus to one or more, so it would be like this, I guess. Like this?
Yeah, yeah, but yeah, no, in those cases they are stars because we can have zero, right?
Oh, okay. That makes sense.
Okay. So we have like a file, like it's literally that. It will not change it like today.
Yeah.
Yes, right? Okay, so expressions. What are expressions? They can either be literals. Okay, they can. Well, it's already right. We are describing everything.
Yeah.
But if you go inside them, we need to describe them properly. So a literal, you have like describing the literals. You don't need to specify how
Yeah. Which
are
is
those
that would be
shards.
verbose AF.
Yeah. So variable is already done also. Like it's literally just the identifier. Like what is a valid identifier for us?
Yeah.
In the future, we can have like different kinds of identifiers because
Yeah.
reasons.
Yeah.
Uh,
Because reasons.
yeah, like we just haven't. Then okay, we have conditional application and abstraction. What do you think? What do you want to do first?
Yeah, the application. I think I have an idea that it is three things, right?
Mm.
Um, I kind of want to. Yeah, I don't know how to express this idea. I'm gonna try. I kind of want to create just for the sake of the grammar. I know it would be a sin to use this
Mm.
name, but I kind of want to use it anyway. To have a type here, which is just as in string. So you can have this, and I don't know, list of some sort.
Wait, I'm not sure what that means.
Actually, because we are not actually specifying the literal, we are being very high level. Just forget it. So it's gonna be just this.
Abstraction list. But okay, but what does that mean? Like you have on the left an abstraction and the right a list?
Yeah.
Yeah, but that's like in a bunch of stuff. Um, so first of all, you see that there we are not using the delimiters
Uh, here
in
we are
application.
right because application is an expression, and an expression is always is
No, no,
always.
no, 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 it's not.
Oh,
We are
okay.
not.
This is just an expression. That makes sense. Yeah. Okay. That's
Yeah.
fine. That's fine.
Uh, wait. Okay, application, right?
Yeah.
First, okay. First of all, abstraction there. Yeah, that's a lie. It's actually an expression. It could be any expression.
Mm. Okay, so we actually need to change spoon as well.
Hmm?
Yeah, because spoon is calling this abstraction.
Oh, okay, yeah. But take a look, take a look. It's calling. Oh, fuck. Oh, yeah. I'm not sure if that's a misnomer. Maybe, yeah, it can be also a misnomer. But go there to spoon.
Here.
You see what we are calling the abstraction? It can be any random expression. We are expecting to be an abstraction, but if it's not, it's a valid AST. It will just not type check, it will not evaluate. But
Oh,
see,
I don't know if yeah, definitely, but we're not considering that, right? We are
we
always
are.
no, we are always assuming this is an abstraction, I guess.
No, yeah, but if you see there, we are pattern matching. If it's a closure or a native function, it means that it
Oh,
is
okay,
abstract,
okay,
right?
okay. So we're calling this like we have a ambiguity.
Huh?
Yeah, that's we are using one term for two separate different things.
Oh, okay, ambiguity in the sense of your our naming, right?
Yeah, exactly.
Oh, okay. Yeah, that was a misname. So, okay, expression. First of all, well, not first of all, but we are not using the delimiters is already, so we could add them, right? On the left and right delimiter. We need
For the
those in the
application.
application. Yeah,
Do we?
of course, it's Lisp.
No, no, no. But we already have. Wait. Lisp has S expressions, man.
Yes.
But we
Oh,
are
okay.
making a separation between them, and
Oh,
this
yeah,
is
yeah.
basically this, right?
I forgot that. I forgot that. So yeah, we only need like one of those basically. So we can like erase either application or S expression, like one of those because they are. Well,
I don't think that's correct because I think that Magetta
oh,
wants to make the pattern
yeah.
matching also as an S, be considered as an S expression.
Yeah, but
Yeah, yeah,
this.
yeah. So this is what we are trying to express grammarly speaking, right? So you
Yeah.
see here that we have delimiters, but this is not
Yeah.
like an application.
Well, that yeah. Yeah, I see. I see your point. But the problem there is with naming, in the sense that you see that pattern matching. Technically, it is an S expression, but yeah, you're right. It's not an application because it needs to like match specific
Yeah,
strings.
it needs to do something else.
So yeah, you're right. So we need to like use S expression in a way to. Okay, S expression needs to be a function.
Wait, what?
Uh,
I'm confused right now.
like okay, so S expression is abstracting the idea of having a left delimiter, a right delimiter, white spaces some places, a list of something, like of something, right? So you see he's abstracting over an idea.
A list, you said.
Yeah, like yeah, but that's also a problem. I'm not sure if you can use that abstraction to describe specific things like special forms, like match.
Oh yeah, we actually do. That's actually a good point. Let's add somewhere special forms.
No, wait, no, no, that
No,
doesn't make sense for
no,
now.
no. Oh, no, but we are already not going with the simplest way because you're already considering this. So we are already not tackling this, the simplest.
Yeah, you're right, but yeah, but what I mean is what I call a special form. It's a condition, for instance, a match. Like they are not a specific.
I think.
Okay, let's just okay. Let's do the following. Let's do application, and let's do it even if it's redundant with as expression. Then we discuss about the stuff because
Okay, so I
ah
want to add delimiters to this.
yeah, like just for now, just for us to visualize something, right? Before, after.
Like this.
Yeah. So okay. So let's do the following. The first thing is we need to describe a list, right?
Yeah,
Like
we do need
they
to
are
describe a
not
list.
As of now, we are describing just the expression and list, right? No, no, let's not. Yeah, we can do a thing like that for describing the list, but you see that in our meta language, it would be kind of a function in the sense that it. Oh fuck, that's so hard to talk about or to explain. At least I'm bad at it. Uh, okay, Lemos. So
Yeah.
okay, you see that if you describe a list there, it will be of a fixed thing or a specific thing.
Mm,
So right there, you would be defining a list of expressions. You could not define a generic list.
but we kind of need, right, to have a generic list here.
We don't need in this case. It would just like be a proof future stuff.
Wait, I'm confused. The application, as far as I can tell, always grabs an expression and a list of what we call in Spoon arguments. And this can be anything at all. It can be whatever.
Yeah, I'm so fucking tired. My sleep is just a mess right now. Okay, but what I mean is, you know that we can either inline it or abstract, right?
Yeah.
So the
Okay.
choices we have is either we align with the specific stuff, or we abstract with the specific stuff that it lost a bit of the why we are abstracting, or we can abstracting being generic, right? So okay, what do you think it's better in this case?
I like the idea of abstracting stuff because then it's easier. Like it's not a ginormous line, like a very
Okay,
very long line.
so on list there, put parentheses. F is F as if you were defining a function.
You mean like this?
Yeah, that's like no. After the
Oh, like
yeah
this.
yeah. So that's like a function in our meta language to
Yeah.
describe grammars,
Okay,
right?
that's fine.
So like pick a name for a argument there, like element. I don't know something.
But these lists can be a list of expressions or not? Wait.
It can if you are doing that, you are abstracting over something, right?
Yeah, so it's gonna be like this, I guess.
Okay. Do you also want to abstract over the delimiters, or they will be fixed?
The delimiters for the list, I think they will be fixed. Yeah.
Okay. So you can just write left delimiter, right delimiter.
Wait. I think that the delimiters for this is kind of the space.
Hmm? No,
Yeah.
no. Delimiters, not separators.
No, but if you take a look on the example,
Hmm.
uh, like this is not an application, but you see that we are separating this identifier from the elements using space.
Yeah, but that's what I just said. Like, I'm talking about delimiters, like the brackets, not the separators.
No. Okay. So it's gonna be left and right.
Hmm.
Uh, right.
Okay, now we have the middle, right?
Yeah.
The middle will talk about separators. In our case, it will be fixed, right? It will be white space.
Yeah.
Uh, so, okay, what we can do is the following. Da-da-da. So, a way that you can describe.
I think the expression that is coming from here, it is in the middle here. That's just a guess though.
Uh, how can I say it?
And I think we
Uh,
can use white space in this case, but it's not.
yeah, yeah.
But it's not star. Like you need to have at least one.
No, no, it is a star. It is a star. You don't need one.
You don't need one.
Yeah, you don't.
Do you agree that? Imagine that this is we are describing how we are separating the expressions inside the list, right?
Mm,
How are you gonna
yeah.
separate? Oh no, but we
Well,
already
but
have the delimiters, right?
yeah, we don't need
Yeah,
the
so then this
first.
can be star.
Yeah, but okay, that's the thing. But as we have now, what is that describing? Just as an exercise.
Uh, I Actually, I think to not get this confusing, I'm gonna put element in here.
Oh yeah, you did the expression.
Yeah.
Okay.
Uh, okay.
Oh, let me just send a message here first.
Element. Okay. This is describing how the grammar of the list element, I guess.
Wait. Okay, I'm free. Uh, so you were saying?
I think that this is describing the grammar aspect of how of the like the internal guts of the list.
Yeah, I don't want that high level description. That's not what I meant. What I want is if that was a parser, like suppose those are like specific on how to parse, what kind of thing would that be parsing?
Do you want the names of the parsers? I'm not getting the question
No,
here, I
no.
guess.
Okay. So for instance, what we are parsing there is left identifier, any amount of space,
Yeah.
a element in the middle that can be arbitrary, right?
Yeah.
Then we have zero or more white space after, and the right delimiter,
Yeah.
right? So you see that's not a list. That's just something enclosed in delimiters and white spaces, well, optional white spaces
Yeah, we are not portraying this idea in this
of
description.
list, right?
Yeah.
So what we can do is the following. So enclose, well, one way of describing it, I guess. So enclose white space and element.
Enclose white space and element. What do you mean by enclose?
Wait just a second. Can we do it both? I don't think we need to. Okay, let's do the following for now. Yeah, enclosing the sense of put them inside some delimiter like brackets, but they will be our meta language delimiters, right?
Oh, you mean this?
Yeah. No, no, only from the first white space to the element.
Oh, here.
Okay, so that's kind of forming like a new node, right? But inlined.
That's
And
forming. Yeah, but how are we gonna explain the idea of
many.
multiple? Yeah, many. Yes.
So literally the star. Yeah.
Okay. Okay. Okay.
So
Yeah,
you
but we
see?
need to be aware of this. So the brackets. This is in the meta language. Yeah.
Yeah, the meta language.
Yeah.
Um, so let's see if that's correct. If that's really correct, right?
Yeah.
So first of all, we have a amount of arbitrary. Oh, maybe that's wrong. Can we have a list with well? Oh, it's right, right? We can have a list with zero.
No, but if you can, we need to start here, don't we?
No, no, we already have the star. I mean, uh, an empty list would be you
Oh,
see what.
okay, okay, okay. No, makes sense. Makes sense. Go on.
Yeah, but then that is the thing. Then I don't think we would be able to use that to describe an application because we would need to describe somewhere that is at least one element, but the list doesn't do that, and it doesn't even make sense to do that, right?
I'm confused. Why we cannot use this notation for application?
Okay, so you see that this is defining a list that is either empty or have n, right?
Yeah.
So the application always needs to have at least one, right?
Yeah, but then we use the plus.
Yeah, but how can you in the application using the list function describes that? Because what you are describing there is that you have multiple lists, not that you have a
Oh,
list
okay. You
with
want
at
that?
least one.
What we want is a constraint.
Yeah, so how can I
We need
do
to
that,
create a
man?
constraint for our meta language.
No, no, that would be too complex, Lemos, for sure.
Yeah, but we need a way to say that this list cannot be empty, right?
Yeah, I think the way it's duplicating code. Well, yeah, duplicating your stuff.
Ah, okay. So grabbing this line and literally just adding a new one here.
No, I mean, do we like do the things inside the application, right?
Um, I don't know.
Yeah, I'm start to thinking that this list abstraction will not be useful because besides list itself, like list in the language, that will always be a oh fuck yeah.
Uh, what is the name, man?
Wait, Lemus. Oh man, my brain hurts.
Yeah,
Uh,
thinking meta, man. It's uh, like this.
so, oh, that's horrible. But hey,
And here would be a non-emptable.
yeah, this has so much problems, Lemus. Okay, so okay, so let's go step by step. Let me try to use the energy that I have. So let's talk about non-emptable list, right?
Yeah,
So that's a list that will be used like at least for our case specific to an application, right?
yeah.
So if you are using only for that case, then it doesn't make sense to be an abstraction over something, right? It is a specific stuff.
No, it isn't. Wait. No, it's if it's a no, but I don't want to put this in here, man. Like this in ginormous line in here.
No, no, sure, you don't need it. I'm talking regarding his abstraction over an element. But yeah, it could be that way. Like if we are going to use that for something else, right?
Yeah, but now the question becomes: do we have a specific use case for the emptable list?
Yeah, I don't think so because even the list of the language itself, it's probably an application. No, not an application, but well, let me see. Yeah, it is an application. Like it's literally an application of like the variable called like list or something,
No,
right?
just for now. So let's just remove this and live with this.
Yeah. So okay. So you need to pass the argument, right, to expression. Well, to non-emptable list.
Okay,
The
so
argument
it's gonna
is
be an expression.
yeah, but how are you pass? Okay, yeah.
Okay, so to apply to our
Oh
meta,
no 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 no
to
no no!
apply.
Come on, no, come on! You're using Lisp too. That's so confusing, man.
No, no, but we are defining a new language like right now, like ad hoc freestyle. So,
Yeah, yeah, but take a look on non-emptable list. You are not using Lisp style. If you are using Lisp style, there, it's confusing as fuck.
no, we are using Lisp style. The only difference is that
No, take a look.
Lisp
You
would
have
define this, man. It's Lisp now.
okay. You are killing me, like brain power right wise, but that's okay. So okay, see now that you have expression there.
Yeah.
Oh no, actually, we don't need more like left identifier there. We don't need the white space there. We don't need the expression there. Like the application is literally using the non-empty list applied to expression. That's literally it.
Uh, wait.
Everything except the non-empty list application on expression, you can delete it from this line.
I don't know if this makes sense.
Think about it for a bit. Let me turn the light here.
Because this is what we are applying to this, right? If I'm not mistaken, maybe I'm wrong.
Oh fuck, I was muted.
Oh, okay. Okay,
So
so my what I want to say is that this we are applying this to this, don't aren't we?
no.
No. Oh. So
Yeah.
I have no idea what we're doing then.
What we are doing is we are receiving a list of expressions. Then we already have what is being applied on and what are arguments.
I'm really confused. Can we use an example from here?
Yeah. By the way, man, I'm having headaches. I don't remember the last time I had headaches. Like
Oh, that's bad, man.
it's gonna be have like years.
Okay, so do you agree that this is we have an application here?
No, no, let me write something in the chat because like
Feel free.
that's just verbose. I will
Oh, I totally
every
disagree. I'm
time.
already totally into this now.
Oh no, man, you are AST junk right now.
No, man,
Is it
I can
is it
read it.
junkie?
I can read it. So.
No, no, I mean AST junkie in the sense that you are addicted in AST instead
No, I'm
of.
not addicted. I'm just saying that now I can read this normally.
Okay, but let me like write in the chat in a simpler form.
Yeah, but for me, an application, we have a body of a thing that is an expression potentially, and we also have things being applied to it. That's the name, application.
Okay, so take a look on the chat.
Um, yeah, I don't think we're doing that. I
Okay,
really don't.
so
What are you doing, man?
uh, my brain's not working properly, Lemos. That's hard as fuck. So okay, let me go through that. So you see where I typed in the chat, right?
Yeah.
That's like as an application would work in a language like Okama, right?
Yeah.
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 But that's the thing. Uh, in Lisp, okay, in OCaml, do you agree that there is no function in OCaml that has zero arguments?
No. Yeah, we don't have that there.
It's literally only one ever, right?
Yeah.
So, okay, in Lisp, do you agree that we can have zero, zero, or many?
Because of the parentheses, right?
Yeah.
Yeah.
So, do like a function that doesn't receive anything.
Yeah.
Like, right? So, yeah, you saw that. Mm. So, see, we can have a thing to be applied on, and it is an arbitrary expression. It doesn't need to be something specific. And then we have a list of arguments, right? Like that describes our AST, right? As you see.
Yeah, but do you agree that let's pick this? So I'm assuming that these less than and greater than
No, no,
are the
wait, wait,
limiting
wait,
the
wait. It's
list.
because you already have the answers there in the screen, man. So, like, you agreed with the ST, right? A thing be applied on and arguments, right?
Yeah.
So the arguments could be empty, right?
You mean this?
Uh, yeah, but in the sense
Okay.
I'm not describing a list, right?
Yeah. Okay, go on.
But okay, it could be an empty list, right? It could be like empty arguments.
Yeah.
So
Okay.
on the ST, it could appear that way, right? The arguments are empty. Uh,
Yeah.
so yeah. So if you take a look on non-empty list, what is that? Is a list with at least once. The head will always be a function because it's required. The rest of it, they are the arguments. It's literally using head and rest.
Yeah. I'm
No,
still not getting like for me this is
really.
this.
And it is. That's why we can all delete all the rest.
No. But I disagree with that last part. If this
No,
is
no, no.
this,
You didn't. No, you didn't highlight the expression there. You
I
highlighted only
no, I
the non.
highlighted this.
Yeah.
I highlighted
Oh, so, oh
both.
wait. So sorry, sorry. Let me increase my brightness here. Sorry for that. Okay. So okay. Do you want to know why that's wrong? Because the non-empty list can be well. Not that it can be. It is non-empty, right? So that would be saying that we need at least one argument, and that's a lie.
Yeah, but wait. Oh, wait.
Like you have a required expression there to be a function, right?
Okay, but no, wait. But in our case, then this would be correct if you want to keep both.
Uh, kinda, yeah. But no, why that's wrong again? Because since you are describing a list and you have delimiters, then you are passing literally a list.
Man,
And
I think talking like this is so confusing. Let's make an example here.
okay,
So let's imagine that we have, I don't know, the
wait.
delimiters are.
Can we open like VS Code so like we can like share stuff and you
We're
can
gonna
show
lose a
on
lot
screen?
of time doing that way because I have
So
to do
okay.
the hacking stuff because of NixOS
Oh,
impurity
so
stuff.
let me type in the chat because it's easier that way.
No. Let's
So
make an application example in Silverware. That's easy.
no, that's sure is not.
What are you talking
So
about? It is easy, man.
what you are describing, Lemos, it's the following. Like, well, it can be easy. It's not easier. And why is that? Because I'm already finished.
After you talked, yes, of course. You talked, you gained time. Now you can.
Well, it's easier than we would take just to take a
No,
look
you
on
are
the spoon
still not
syntax.
getting my point. This is still more complicated than what I'm suggesting. Uh, I'm not
No,
talking about the
Lemos.
grammar now. I'm just having. Okay, I want to have an example. If you prefer, you can do it in, I don't know, in Haskell or in Nekoma. I don't really care. So let's suppose that we have something like, I don't know,
Oh, I'm tired.
this.
Hmm.
Isn't this an application?
That's not.
Oh, that's not. So I'm confusing with abstraction again. This needs to be ready, right?
Okay, we are talking about Lisp, right? Or are
Yeah.
we not?
I don't care. Imagine that it's Haskell.
Okay, yeah, that's an application.
Yeah, that's fine. So this is the our list of arguments. Would you agree with that?
No, I wouldn't.
Okay, so what is this then?
This is a expression.
No. You are
As in,
mixing the grammar now. No, forget the grammar for this moment. I just want to get the names right.
no. Yeah, I'm not mixing. Like, talking about languages, that's an expression. And it is literally one, like, always, to be an
Yeah,
application.
but in our case, this is the arguments. We are separating between having an
The
expression.
argument is an expression, Lemos.
No, but that's fine. I'm not denying that. I already agreed with expression being
Okay.
here, right? So this is an
Mhm.
expression, but in the case that in the context that I'm talking about, this is the argument for this.
Yeah.
What's the name of this?
Well, that's an
This is
expression
an
also.
expression. That's fine. I agree with that. So in my mind, that's where the confusion is coming in. In my mind, this is this.
Okay. Okay. So easy way to figure out that then. If you are using non-empty list there, this function,
This shouldn't be here. If this is known, I agree.
yeah,
Then this needs to go.
yeah, and the expression would be the head of that list.
Yes, but I think it's really more confusing to understand that way.
Yeah, but do you know why you doing that way is wrong?
Why?
Because
That's what I
of
want to
the
know.
limit, because of the limiters, basically.
Uh,
Non-empty list is requiring you to have delimiters, right?
Wait just a sec. Okay, so what we are saying in this grammar is that we have a delimiter here and a bunch of white spaces. Then we have an expression which we are defining to.
Like that's it already. Like your
Yeah, no, but
function,
this
right?
parenthesis is here.
No, just
Mm.
take a look at them as only like syntax for making abstraction.
Oh, okay. So we have then an expression. Then we are
Hmm.
saying emptable list. Emptable would be like this. So we have another delimiter,
Yeah, that's the catch. You
and
see those
then
delimiters?
wait. And then we have potentially multiple white spaces and elements.
Hmm.
Then we have more white spaces, then a right delimiter,
Yeah,
then
and
more white
another right
spaces,
delimiter.
and then more another delimiter.
So you see the inner delimiters?
Yeah, these ones you're talking
Yeah,
about.
they
Yeah.
shouldn't be there.
Really?
Of course, man. That's Lisp.
But in Lisp we do have delimiters for those.
We
We
don't.
have this.
Lemos,
We have this.
take a look on the chat. Does that has delimiters on the arguments?
Mm, okay. Okay, so we don't have delimiters in here. Now I understand your point.
But yeah, you're right. We can describe it in another way, and you could do that way if you prefer, like if you think it's more intuitive. But we would need to like modify what non-empty with those things are, right?
Yeah, we need to remove this
Right.
and this and this
So let me see.
and this. What do you think?
Yeah, but then there is a thing. Then we don't need to do that anymore, right? We can literally just erase I can't pronounce that right now. Give me a second to take a sip of water.
I can't.
Mm.
I can't talk.
Empty, emptyable, emptyable, empty, empty. Okay, that thing there, we can literally just delete it because like it's too specific right now. So okay, let me read that. Left delimiter, it can have spaces. It has at least one expression that's really well described there, right?
Yeah, I
And
agree.
then we have many. We have many of. Okay, yeah, that's really nice. Lemos. That's really nice,
No, okay.
and I think it is correct.
Okay.
At least one. The other can be zero. We can have white spaces on the. Oh, wait. But, I think we are doing something wrong only with white spaces.
Hmm.
Yeah, it cannot be zero, right? So
Let's do
that
the
one.
exercise once more. I think I'm learning more doing this
Wait,
way. So
wait.
this
Yeah,
white
just one thing.
spaces. Then we have an
Lemos,
expression.
like you see the second white space on application. Just change
Uh,
that to a plus.
this,
No, no, the second one.
this.
Yeah, think on why. Yeah, you change and now think of why we are doing that.
Oh, we need that because otherwise we're gonna have two like this, and we want like this.
Uh, kind of, but that's
Kind
even
of.
impossible. Yeah, because suppose the two expressions are variables, so then you cannot separate them. They would not.
Oh, it's
They will
even
never
worse.
be.
Okay, that's
Yeah.
correct. It's even worse than what I thought. Okay.
So
Yeah.
okay, I will just eat a little bit while you do some reasoning there, right? If you ask something, just ask, and I will stop a bit here.
Yeah, I'm gonna write this, and I think it's smart to meta language. Okay, so what is
Are you
important?
describing the meta language with the meta language?
No, 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 no.
Just text, please, right?
Yeah, just text. One or more. No, it's the opposite. Zero or more. This is the plus, and this is the. It's describing the meta language using the meta language. Oh man. Um, uh, options. Um, uh, I kind of want to do this.
That's a lie.
It is not in our case. This is
It
doing the
is.
exact. No, it is
We
exactly
don't
this.
have types.
No, no. That I want to explain first. The idea that this is reminding me is some type and product type, but I don't know how
Why
to
don't call alternatives?
because alternative has a name like in the
Some type
parser.
also.
No, sometimes yes, but I'm trying to figure out.
I think it's pretty intuitive, but yeah.
Options. Um, Mandatory, maybe? This is pretty
Like
hard to explain.
I don't remember the proper names, but I think that the different things that we have between the pipes are called like production rules for a given like parsing piece, right? So that's like literally describing the most like thing. It's a thing for you to have like multiple. Oh, by the way, that's a syntax sugar. By the way, yeah, I don't know how to describe it. How to say it. What is the mandatory? Is an empty space? What the
Yeah, it's the
fuck?
space. It's
Can you
this.
explain me that?
Yeah, because to be a file, you have to have these three parts. That's why
Yeah,
the
that's
prototype. That's why the prototype was in my mind.
yeah, but you see, you
Expression,
are
you don't
not.
have to have all of those. You can be any of those.
Yeah, but they are mandatory also. Like the mandatory is not describing where you want them.
Yeah, I know, but I'm trying to find a better word for this. And this is this.
I don't think you need, man. Really. But you could use an and to describe it.
Mm. Okay, so or logical operator. This is an and logical operator.
Brackets, you could just call it grouping.
Oh yeah, brackets. Good catch. I forgot about those.
Man, what the fuck? You don't need to define the equal. Come on.
No, 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 no. We are precise.
If we were being precise, we would be using other language, not that invented one.
No. You are you are removing the fun out of this project. I don't know why you do that. Yeah, okay. I'm pretty satisfied with this.
Literal.
Um,
What I mean is, on the meta language, you are not describing the literals, things that are quoted.
oh, okay. We also should do that. Oops.
Why are you doing the integer and naturals thing?
Because what I really wanted is to put LaTeX here to use the natural set.
Man, why don't you do like natural or digit or something? And with a plus, like, I don't know if that's what you want to describe.
Oh, I want to describe the math set of naturals, like the Greek the fancy n. You know?
But you are already being heretic. You are saying that integers are equal to natural.
No, but in our language they are. Just in our language.
Then they are not
Are we gonna
integers.
have negative numbers?
I have no idea.
Yeah.
But
So.
well, they are useful, right?
Uh, okay. So let's put. Ooh, this is hard.
Man, you don't need to go into specifics on what describe an integer there. Like, let the parts do it.
Okay. Uh, okay. So you said something about what? What did you say? Oh, this the quotes. Yeah. Okay. So. Um, I don't know this string literal.
Mm. Okay. So are we done with application? Um,
I believe so. I think so.
yeah, I also think that's the case. Yeah. Mm. So what about I don't know, condition?
Condition. Uh,
1 second.
I think you're gonna have a left delimiter, a white space, potentially zero or not. Then you're gonna have a string literal.
Back.
If and white space this, then a predicate, then white space.
Mm. That's a bad, no, not a bad thing, but in the way that we are doing like parsers combinators, like doing the tokenizer and like quote unquote parser itself, like in the single pass, right? In the single way, uh, is that we have to like deal with white spaces and shit, right? Because normally you would just, oh, on the tokenizer, you remove all of them. And then on
Uh,
the,
I agree with you, but this is just annoying just because we already defined it unanimously that our language is not white space sensitive.
oh, yeah, yeah. Otherwise, oh, okay, yeah, that's a good point. If you're defining one, you would like that, right? Yeah.
Yeah. Uh, expression. Um, white space.
Mm, wait, isn't that the plus that you're wanting?
Oh no, yeah, this is a plus. Sorry, this is a plus.
Also the one after the if, right?
I don't know. Maybe we want C style. What do you think?
No, wait, it's not possible, Lemos. Uh, if and a variable after
Oh, it's
without
gonna be, yeah, it's
spaces.
gonna be inconsistent. Yeah.
No, it's not inconsistent. It's impossible to parse.
No, it's
uh,
not.
th-
But yeah,
man,
okay.
man, how do you do if
It's gonna be
no
like this.
spaces?
Yeah, if brackets, and then the next, and then predicate here.
Oh,
Yeah.
no, man. No, take a look. Okay, I don't know why you are writing predicate there because it is an expression.
No, it is an expression with a constraint. I mean, we're gonna define later.
No, that is no constraint.
Then it's wrong.
Then it's not wrong, man.
It is wrong because if you have an expression that ends with an integer, that's wrong.
It is not on the parsing levels. You're talking about AST stuff.
No, in the wait.
The parser.
Oh, you're right. The parser doesn't care if it's wrong.
Yeah. So see, now take a look. How do we do a if and the variable after without having spaces?
Oh, now we need a space because this is an expression, and an expression is not predetermined to have white spaces.
No, that's not because of that. It's because it can be a variable. So if the variable is x, then we have the
Yeah, but
string
that's
x.
that's that's what I said. If the expression already had white spaces surrounding it, that wouldn't be a
Oh,
problem.
yeah, you're right. Yes. Wait, is
Expression.
it?
I think so.
I'm not totally sure because. Wait. But only if you have pluses, right? Yeah, but yeah.
Now we need.
Let me see. Left the
We
meter.
have we need to write the demeter now.
If x rush.
I kind of want to start indenting this crap. What do you think?
Wait, just a bit. If expression white space expression white space expression. Oh, we are done, right? It's
No,
just like
we need to write delimiter, but
no. I mean, it's just like white space many, and then water delimiter,
yeah.
right?
So I'm thinking about suggestion. What do you think about? Oh, wait.
Hmm?
Oh no, we can't do that because of application.
What do you mean?
I kind of want to fix that the expression always needs to have white space plus surrounding.
Man, that's not a fix because that's not an error problem.
No, but we would just add in here. But the problem is that sometimes we don't want that.
I think that doesn't make sense. Like an expression shouldn't have like white spaces in it necessarily.
No, it doesn't need to have that. But I'm not seeing anything here aside from application that is being problematic about that.
Problematic? How
Yeah,
is application being problematic?
it's because the only one that is not following this rule at the moment is this one
Which rule?
of having to add white spaces surrounding the expression.
Okay, what I meant by that is you are seeing the expression node.
Yeah.
Doesn't make a sense to have white spaces there.
Wait. Oh, you're talking here?
Yeah.
Why not?
Man, because that's not part of an expression. Like we don't need them to.
No, that's exactly what I said. I'm not saying we need them. I'm saying that
Okay,
it would be nice to shrink this.
man, I think you are doing the wrong abstraction in the sense that, sure, you can diminish the things you are writing, but it will be with a wrong abstraction in the sense of
Not this
either the
abstraction.
yeah, not this abstraction,
Yeah,
in
yeah,
the
yeah.
sense that is either how can I say more in direction in wrong ways or just the semantic is off in some way.
Okay,
It's
no, that makes sense. That makes sense. I am trying to be pragmatic. Magetta would say that. I'm trying to be pragmatic in this case.
by the way, that's not being pragmatic.
Yeah, I am. I'm just doing something just for the sake of being easier to write stuff instead of seeking if it's correct or not. It's exactly the definition that Magetta has a problem with.
Yeah, then I think his definition is fucked up, I guess.
Yeah, there's a lot of people that works like that, by the way.
Yeah, but I wouldn't call that pragmatic because I don't think it's pragmatic for you to shoot on your foot.
Oh, but the battles that you would fight saying that. I agree with you, by the way. But that's the thing. I was not being like seeking what this means, and you're correct. Now, semantically speaking, an expression not only doesn't need, but in our case doesn't make sense,
But
which is fine.
man, the condition is pretty beautiful, right? Like, isn't it?
Yeah, it's pretty nice, right?
Yeah.
The meta language is not that bad. That's why I want to make one, because we have control over it.
Wait, what did you say? Can
Uh,
you repeat the
yeah,
beautiful part? Not as bad.
I think it's part of it being beautiful is that I like this way of describing stuff.
Oh, okay, okay. I thought we were talking. Oh, our language is not that bad.
Well, based only on this, the language is not bad.
Oh, okay. You're talking about the meta language or
Yeah.
the language?
No, I'm
Oh,
talking
the
about
meta
both now.
language.
The meta, I think that the condition is pretty nice because I think that the decisions that we made for the meta language, they are okay.
Can I tell you a secret?
Yeah.
That's that's pretty much what people use it. We are literally just changing the equal sign
Yeah, no, but for me
and,
that's fine.
and some angle brackets.
Yeah, but the angle brackets for me make it that much worse, man.
No, actually, they have a great importance, Leon, but that's okay.
I don't like them. I really don't.
But yeah, it's okay. Our meta language. The language, though, I'm not sure.
Hey, it's based only
Wait,
on this. It's fine.
no. I mean, if it. Oh yeah, based on that, it's fine. I mean, the implementation, right?
Oh yeah, the implementation is complicated to defend, but anyway.
Abstraction. Let's go.
Yeah, so how are we gonna make the abstraction? I think we need to start with a left delimiter.
Oh fuck! You do need to use a list there.
Wait, why?
But
I'm confused.
the arguments of an abstraction are a list.
The arguments.
Take a look on what I'm
Uh,
writing. Just imagine that I'm dealing with white spaces. There are either zero or more identifiers. Don't look at the fucking ESD, man. Come on.
no, I told you this in the beginning. We cannot ignore this.
But that's true. But man, you need to do some really fucked up shit to to write a thing that you'll not be able to spit a correct AST out of it.
Yeah, I agree, but anyway, I like to look at what we already did, right? This is already done.
That's
Okay,
fair.
so you're saying that we have a list of identifiers.
Yeah, but oh okay, but yeah, I'm not considering some things, right? But yeah,
Um,
let's just go. Like you will see when implementing.
yeah. No, I'm just thinking if the variadic information is changing your statement. I think the answer is no.
I'm not considering that, but
Yeah.
it's so easy to add.
Um. Okay, so how is an abstractionary language? Does it have a left delimiter?
Of course, it's Lisp.
White space. And now we have grouping. Oh no, it's not grouping. This is a list. Oh, I
Mm-mm.
see what you
Mm-mm. That's a
mean.
keyword.
Oh, okay. Okay, so this identifier.
No, no, wait, the keyword.
Oh, now I remember what you. I think you told us this, right? During spoon sessions. Oh, we
Hmm.
need to implement list at some point.
Hmm?
Yeah, do you remember that?
No, I'm not sure what you're talking about.
Like during one of the spoon sessions, you said something like, "Man, we need to define how to express list in our language."
Oh, okay. Yeah, it has nothing to do what we are talking about today, Len. Not at all.
Wait.
Totally unrelated.
Now I am more even confused.
Okay, so what I'm saying is, abstraction is a lambda expression, right? It's a an anonymous function, right?
Yeah, it's something like this, right?
Yeah, yeah, exactly. That's my point. So you see, how do we recognize that that's a okay? No, no. Oh, write one in Lisp, please. That's yeah, that's not the best example. Write one in Lisp, a lambda.
I believe that in Lisp you need to do.
No, I don't think we have the arrow.
Oh yeah, we don't. Sorry.
But hey, hey, why do you have the name lambda there?
To identify it, this is an anonymous thing, I guess.
I mean, only for us, or does the parser
No,
care
does the
also?
parser care? I guess the parser
Yeah,
does care.
then that's what I'm saying. We need a keyword there.
Oh. No. But let's just skip the keyword just for a sec. I want to focus on what you sent. So you sent uh, this. So no, not this.
Okay,
This.
that's a good example. You saw the lambda that you defined.
Yeah.
You saw the x to z.
Yeah.
That's what I'm talking about.
Mm,
It can be empty. It can be many.
yeah. So is this can be empty?
Mm,
There will be some keyword here.
yeah, like first of all, put the delimiters, right? Need the delimiters.
Left.
Oh, and do the keyword as like literally keyword, just for us to have some kind of placeholder, right?
Yeah. Then you have this. Then you have. Oh man, I'm gonna have to write a bunch of white spaces because you can have this, I guess.
Oh yeah, yeah.
Ah, crap. Okay.
So yeah, and the thing is, that's
Yeah, this.
well, we can like abstract after, right? Like put in other
Yeah.
place. Okay,
Uh.
just 1 second. I will just get some more bytes.
Okay.
Not the zero. and one bite, like food bite, you
Yeah,
know?
yeah, yeah. That's why I'm laughing though. It's a really weird state. Oh no. And then we have white space. And I guess this one we actually need to put a plus and then expression. And then uh, white space this and then right delimiter. Holy Jesus. Okay. So I guess this is the one. Uh, for now at least, arguments. I'm gonna put this.
Hey, we need
Mm-hmm.
some white spaces, right, after arguments?
Yeah.
And the other thing is, that is a good thing. Lemos, what do you think about that? Uh, do you prefer to have one expression? Yeah. Do you prefer to have one expression as a body of abstraction or multiple expressions,
Can you
like
repeat,
prog
please?
n by default? Yeah. Okay, so I will just write the
No,
code
no, no.
because
I
it's
was just not paying that much of attention. Sorry.
no, yeah, yeah, but I mean that's not a problem. I mean I will write because it's easier to see.
Which keyword should we use, man?
Fun, lambda, whatever for me.
No, yeah, but Magneto will have a war about this, I guess. A battle.
No, but Magenta can choose the thing. Like we can literally put just keyword and then he chooses one. Like we don't have to fix one now, right?
Let's put lambda for now.
Okay. So okay, let me do that way.
And yeah, I know that we are not expressing types, and I know that's gonna be a real hassle at some point.
Not really.
Uh, expression
What
white
is
space.
that? So take a look on what I just wrote. Again, disconsider white spaces.
Yeah. So, what
So,
is the suggestion here?
oh, okay, sorry, sorry, I forgot to explain. But the first one is what we have. The second one is what some Lisps have. And what does that imply on?
Oh,
It,
using or not using prog n.
yeah, basically.
Okay.
So
I
basically,
kind
it
of
has a
like
implicit proc n
I
by
kind of like
default
having the implicit
on.
prog n though. I need to be honest.
Yeah, I agree with that. That's my suggestion.
Uh, okay.
Yeah, 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 but we are. Yeah, but we need to deal with more white spaces there. We are not doing that right now.
Are you
Sure, yes,
sure?
pretty sure.
Oh, between the expressions.
Mm,
Yeah. And then we can remove
yeah,
this one.
that's no, no, that's wrong also.
Why?
Because then we need to have the last white space. You just should delete maybe the wait. Let me see. Yeah, yeah. Delete the white spaces after argument and put the white space inside the grouping before the expression as a plus.
No,
And
but
the
we
last,
no, I don't think so. I think this must be the case all the time. This.
it will be. It will be.
Oh, it's because we are using plus here. Okay. So grab this and put it
Change
inside
the
the grouping.
order of yeah. What we have inside the grouping. Let me see. Expression. Now you can delete the white space after, of course. And outside the grouping, you can use a white space with many, right? Like with star, I mean.
Oh yeah. Okay, makes sense.
Let's see. Left delimiter, white spaces, the keyword, then white spaces, arguments. That's a pretty good abstraction, by the way. Uh, then we have the body, right? So at least one expression as a body, and it has one white space and one expression. We can have many, and we can have white space after, and right delimiter. Yeah, it looks good for me. What about the arguments? Yeah, the arguments, they are a bit more complex, Leon.
Yeah.
They're a bit more complex. So, okay, types. Man, we're not able to do stuff without types. So, do you want
Oh
to parse them
man.
already or not?
I don't want to parse them yet.
Okay. We can just use the evolve for now, right?
Yeah, just the evolve for now.
Okay.
That's why the evaluation is, by itself it's useful because you can skip the type checking.
Oh, yeah, it's really good, right? That they are like independent like
Yeah, they
steps.
are orthogonal.
It's okay. Oh, my head is not that good. We were in arguments, okay. So left delimiter, the white space, the right delimiter, white space. Yeah, okay. Uh, how can... Okay, first of all,
Mm.
you see the last white space? Let's put something before him.
Here?
And, yeah, before that.
Okay.
And we are going to use a new symbol in our marriage. Are you excited, Len?
Go. Let me see.
So, okay, so grouping, I guess. Yeah, grouping.
Grouping.
No, you can like close the grouping already. Yeah. So inside the grouping, well, supposing we are using the following notation, right? So you want a literal with a marker. In this case, it would be the commercial E.
Oh, so you do like this. This.
Yeah, and then identifier. And outside the grouping, you do like a question mark. So it could be 0 or 1, right? So now you update our documentation.
Oops. Here. 0 or 1.
All right? Optional.
Yeah, so what's this?
Well, that's the rest, right? The variadic part.
Oh, that's cool. That's cool.
Right,
That's cool.
right. Yeah, but that is the
Mm.
thing. Our identifier is incorrect because he doesn't have spaces. Like the first part of our stuff.
Yeah, that's also. Wait. It doesn't have white spaces.
Yeah. We need to separate them, right?
Yeah, that's true. But now I'm thinking, are we gonna use the same approach that because we could do just this and add a white spaces on that.
Oh, but they always have the same name, right?
Yeah,
Oh,
that's
I
that's what I
see.
want to ask. So does it make sense to allow the user to, well,
Good question. Good question. That's a
I
really
kind of want
good.
to I kind of want to call this tail just for lols.
Oh, that would be fucked up. Uh,
Don't see why, but okay.
wow, because you are lost in the what's the name? You are lost in this name inside
Yeah,
the
you are, but well, we have cads and cadars.
no.
What?
Fuck with that. Fuck with that. I don't want to see that in our language for sure. Uh, man, what about giving the flexibility and people can choose? And well, I think that they usually will choose a no. Yeah, I would say oh maybe would usually choose a convention, but
And why do we need grouping? Oh, because before we were
oh, identifier,
using, yeah,
yeah.
identifier.
But
Okay,
yeah, it
so
could be that. Yeah,
yeah,
it's easy to change also. So
yeah, but I don't know. I'm not seeing also a good argument in favor of this. So I kind of want to.
Like for me, I
No, not
really
this.
wait. What? Yeah, I think
Um,
that both are fine and they are easy to change as we see, right?
so we need white spaces between here,
Uh,
I guess.
uh,
Yeah, something like this, I guess.
yeah, I'm not sure because it depends on what we do in the left, right? And
Yeah,
okay,
on the left we just pass the.
no, no,
Oh,
but the left is not finished yet.
yeah, I just noticed that. So we need
Okay,
to
so
add white space. Um, we need.
uh,
I think this is a star because you can have if you have only one, you don't want to add this, and you're not variadic. You can just not put any white space and just put a delimiter. But if you do, holy, how are you gonna make this though? Oh no, wait. Oh no, that's why we're using plus here. Okay, so
oh fuck, we have a problem,
you can have like this, I guess.
man. We have a problem.
What? Which one?
Oh yeah. Ooh, we have a
Just tell me,
problem.
man.
Yeah, that's a problem that arises for dealing with white spaces there. And basically, it is we have to deal with white spaces in a non. What's this? What's the name? Uh, I'm not sure if the name would be ambiguous, but we need to be careful in how we are describing white spaces. So take a look on the arguments, right? So focus on the grouping that has identifier, right? The left one.
Yeah.
We have
Yes.
a white space star as the last, right?
Yeah. So here.
Yeah. But the next grouping it starts with a white space. One that is required to be at least one. One. So how do we know where one finishes and the other begins? And that's the problem because if you have both, we are processing all the white spaces with the previous one, and then the next one will fail because it has none to process
I
anymore.
think we need to just a guess. I'm not saying I'm correct. And it here. Let's check this.
Wait, it can be,
Left
but I'm
delimiter.
talking about something else. So
Oh,
suppose we are parsing, right?
yeah, we're parsing.
So
So we have the left delimiter. Oh, okay. Maybe this is. There's a bunch of options in this case, but let's assume that it is arguments. So
okay,
let's suppose that we have.
okay, go to the Z on the thing that you wrote there. Go
Yeah,
on the Z, right?
the z will be the last one out of these.
Yeah. So see, the right of the Z, he will consume all the white spaces, right?
Yeah.
Until something that is not a white space, right?
Oh, but potentially gonna have a white space there.
No, no, that's not the problem. It's that we need to have one there, but he will consume it all.
Yeah. But what about removing this then?
Let me see. Left in the meter, we can have.
Oh, we
Okay,
can't have this because we
why?
have to do this because then the x and the y can be together, I guess. If you're doing like this.
Oh, yeah, yeah, yeah. You're right.
Ooh, but that sucks because then you're gonna have to do the first one with the
Man,
space.
hey. We did list, like, and it was the same. How are you not being able to do that? Like,
Maybe the least one was wrong.
I'm not sure, but maybe we should have saved it.
No, but
Uh,
this is recorded, so it's fine.
oh yeah, but I mean, we can't look at it now, right? So
Yeah.
let me see. So confused right now. Okay, arguments. Left delimiter.
Yeah,
Then
this.
you can have arbitrary ones,
Yeah, this
and
doesn't
then you
work
have
because of the.
file.
Yeah,
Okay, let's
that's
do the following. Put the white space like outside the grouping on the left, right?
outside the grouping.
Yeah. And delete them from inside the grouping,
Yeah.
right? And then da.
No, but we need white spaces inside the grouping to separate them, man.
No, yeah, I'm thinking about that right now. But that's the thing. Oh yeah, that's totally a error. Like if you do that and the identifier is optional, then you are required to have one as your last stuff. And if it's a star, oh fuck, man! Like we have problems. Like the white space after the identifier on the first grouping. Oh, you are a fucking genius, right? It is a bad syntax to look at,
Oh,
but
it's
maybe that
terrible.
solves
It's
our parsing
terrible.
problem.
It's terrible in multiple ways. Indeed.
But that would. Oh no, Lemus!
What?
Ah, that's great. That's fucking great. Just delete the e% and let people choose whatever name,
Oh, yeah, that's not so bad.
right?
Oh,
And it looks like Tail.
Magenta will cry, man. But, but that's
Well,
fine.
okay,
That's fine. For
like
me, that's fine.
like I'm not sure if it's fine for me, but if you want to suggest a different syntax, he would have to suggest a different way to parse it, right?
Yeah.
So yeah. But yeah, let's try to parse that, right?
Oh man, but I don't like this. You know why? Because let's suppose
Why?
that you have only the variadic one. It's gonna be like it
Oh, how do we
starts.
know?
No, we know, but it's gonna be terrible, even more.
Yeah, yeah, that's worse. Oh no, man.
Oh no.
Oh, that's so fucked up. Let me see. Is there a better way to describe? Uh, we have a list of stuff. Let's suppose we have identifier, and we need to have things on the right.
Let's remove this.
Need to be at least one. But that's a problem if you don't have RAM.
What about just wait? Why this was not working?
Yeah, this was not working because of. Okay, take a look. If we don't have a rest, then we need like a required white space as the last thing before
Ah.
the right.
Ah. Okay. No, but man, I don't think there's a solution for to this. We need to or we pick a side, or we're gonna have to add to our meta language constraints.
No,
Because
no, no, no. Wait, man, that's the thing. Uh, like we have different types of grammar, right?
yeah.
Uh, they can be like classified in different ways, and that changes a lot, a lot. It changes how do you parse it, and, like performance. It changes so much stuff.
Yeah.
So basically, what we are going for, I'm not sure right now if it's something that is classified as a regular grammar. I'm not sure if that's even the name,
Yeah,
or if
I'm
it's.
also not sure.
But basically, people usually are going for context-free grammar, right? So if I'm not mistaken, if you are adding constraints and shit, if the things that you are passing right now are depending on some other stuff, they would be a context dependent type of grammar, right? And I'm not sure. Yeah, I'm pretty sure we would not been able to parse that even with the stuff that we have. Uh, but yeah, that's why we need to take care with like putting some stuff. We can end up with a grammar that we cannot parse at all, not using parser combinators and stuff.
Yeah, but this one we can. We just have to accept that maybe we're gonna have an extra space in some cases.
No, I mean if you add all the constraints stuff. So man, I prefer having the the pipe rest alone
Ooh.
than having a required white space. See?
Ooh. Yeah,
Ah
but
man.
that's hard to watch.
Yeah, that's really hard to watch. Oh man, how can we? Man, come on, that is a way to solve that. I'm pretty
There
sure.
must be a way.
That is a way for sure.
Oh
Mm.
no. Man, this way of visualizing the grammar, like with an example, is so much better than doing by yourself in your mind. Holy crap.
Not sure.
No, for me, it's sure. I only had the pipe idea because I was looking at this.
The pipe. Oh, okay, yeah. In that sense, yeah. Thinking Yeah, but the way I'm thinking is, okay, we need to have like zero or more white spaces before, just because that's how it works. But then we cannot have a plus because that would make required white space on the beginning. So after that, we need to have identifier.
I'm thinking about removing the white space in the beginning. Let me just check just for a
Really?
sec.
But then it would be
Space.
yeah, but then it would be required, man, on the beginning.
Oh, it's because we cannot allow them to be glued together. Oh yeah, I get it. Okay.
Uh, Let me see. Okay, so after that space, we need identifier. We cannot put another space. Uh, but the problem is, we need also
We need
white
the
space.
plus, man. We need the plus in the grouping. There's no way. Because if you don't have the plus in the grouping, we're gonna allow the variables to be glued together. That's not good. That's
Yeah,
a
but
problem.
we just cannot also have this. Oh, oh, that's so fucking sad, Lemon.
No, wait. Wait. Just a sec. The problem with this approach of not having the white space here, because we have a star here, right?
The whole problem is that that could be an empty list.
Yeah, but if this let's suppose that this is an empty list. How that would look like? Because I'm always going back to this for some reason. So this we can parse, and this is correct according to
Let me
this.
see. Uh,
Yeah,
yeah, yeah, I guess so.
yeah, this is correct. Now let's put something in the beginning here. So this is okay. Then this is a star, so we can have those, which is fine. Then we're gonna have identifier, which is X, white space, which is mandatory, at least one, which is fine. And we can have multiple of those. Then, oh, the
Wait,
problem is
wait.
that this is optional. The rest, and then if the rest is optional,
Yeah,
this
then
is
yeah,
the
yeah.
thing. Ah, I see. That's the situation there. Okay, okay. Now I
Mm,
understand why we are using we suggested the other way.
yeah, I don't think we have a weight song. At
Yeah,
least not one that I can think of. Only
yeah,
using some kind of symbol. And it would be a symbol that would appear as when like we don't have the other's argument, right?
yeah. That's pretty unfortunate.
Ah. But come on, we can change the parser later, right?
Yeah, it's easy to change the parser.
Well, I would not go as far as saying
No,
it's
it
easy.
is easy, man. It's not the hardest thing ever. I completely agree. Have faith on us. It's fine.
Ah, okay. So, what do you think of using the pipe for now? And well, the pipe would appear when it only has the rest.
Yeah, I'm trying to thinking of a better symbol than the pipe, but it's hard.
Oh,
Like for me, the pipe is the best one.
you could literally just change the pipe for a like
Yeah, we
dollar
can.
sign if
Yeah,
you want.
we can
Not dollar
change.
sign, but e-commerce. Yeah.
Yeah, we can change to anything else.
What about the dot?
Hmm, a dot. Just a second, man. I have to go here.
Mhm.
Okay, I'm back.
Hmm. What about the
The
dot?
dot. This is reminding me of the comma, and I hate the comma. But I think the dot is fine. I think the dot is fine. It's less like annoying to look at, so I think that's fine. Okay, so do we have our thing here? Hello? Okay.
It is still wrong. The plus there. It's still the same situation, right?
What? Sorry?
The
What is
plus
wrong?
is still, the plus is still the same situation on the first grouping with white space.
The plus is the same. I'm confused. Where? Your arguments you're talking about?
Arguments. The first grouping, white space.
Oh
Is,
no, but this is something we need to live with. Like I already accepted. We need.
no. What I'm talking about is that take a look. Uh, if you don't have the rest, you still are going to have the required white space
Yeah,
after.
yeah. That's what I
That's
said. I already accepted that.
but if you accepted that, we don't need the dot, and that's a lot worse than the dot. What the man?
Oh, I see. I see. If you
The whole
accept the
point of
white
we
space
adding the
given.
dot, it's we not
Yeah, yeah,
allowing
yeah,
that.
yeah, yeah, yeah. I know.
So
But
let's see. Oh fuck! But that doesn't solve what the
that doesn't solve it, man.
doesn't solve the problem. Oh
Yeah.
no! Wait. Okay, let's think for a second. Okay, put a star there.
We can't.
Just for now, just for the sake of it. Now, oh yeah, we wait. What if we have a white space star before the dot?
White space is star before the dot.
Yeah.
That doesn't change the fact that you cannot use a star here.
Why?
Because then the labels can be unified. Like X, Y, and Z together.
Let me see. Oh, that's not a problem. Oh fuck. Oh shoot, that's not a problem.
Wait, that's
Yeah,
not a
dude.
problem?
Yeah, no, that's not a problem.
Oh, why?
Oh, that's nice. Because oh, that's nice. See, identifier. If they are glued together, then they are one. We would not be able to do it anyway.
Yeah. Yeah.
Oh fuck, that's nice. Okay. One less problem. Yeah. Oh shoot. Wait, does that help us in?
Yeah, that helps because now we have, like, we cannot remove the dot here because we need to separate these potential white spaces from this one, right?
Wait a second. Let me share if we can leverage that to not have a dot and not have a marker for that. Suppose we are using the e-commercial, and if we don't have a space between them, if we have separate, how would that work? Oh shoot! I think we can have that.
Yeah, I'm starting to think that. I think that the problem before was that this was a plus. Yeah. We were not using this before because this was a plus, and then if you don't have a variadic part, we're gonna have to end the thing with a space. But now that this is
Yeah,
a star,
but I'm relying some things that I haven't told you. For instance, you see that you can have identifier, then the e-commercial identifier, right? Like without spaces.
yeah,
So I'm assuming that that's a valid identifier by itself. Why is that? Because in that case, then we don't have those things without white space. We have only one identifier, and as you saw, that's not a problem.
not it's a problem for the programmer, I guess, not our problem.
Yeah, I mean for parsing, right?
Yeah, for parsing, who cares?
So what do you think about that?
Yeah, I have a concern that I was not
We are
expecting.
allowing pretty weird shit on identifiers, right?
No, no. We are allowing, but for me that was not a problem because
Oh,
all
if
the
it's not a
identif.
problem,
No, it wasn't. Now it is.
oh, why?
Because before every single identifier was specifically spaced by a space. Now it's possible to have an identifier glued to
No, no,
this.
no. It is not. It is not. It is not.
No, it is
That's why.
because now no. I'm not saying
It is
it's a
not.
no, wait. I'm not saying it's a problem in terms. Oh, we cannot parse this. Of course we can, but we already have a parser for identifiers. But I need to change it to exclude this
No.
or
Okay.
make a
Okay.
separate one
Wait. Wait.
just for
Wait.
this
Okay.
case.
Let me be clear.
Let me
First of
write here.
all, uh,
X, Y, Z, this.
yeah. See that? Do you know what that is? Those are three identifiers. None of those are rest.
Ooh, so we're gonna allow this shit to be inside an identifier.
That's what I was talking about. The thing that I was assuming, and you said you had no problem.
No,
Has like weird
I
thing
had
on
no
it.
problem but I was thinking that we would be smart and separate this.
No,
But this
no,
is a
that's the
lot
thing.
more work. So
No, no, yeah, being smart and separate them, it's actually a weird thing because then we are allowing them to be not separated by space, right? That's worse for me, I guess.
but in this description we are allowing that, right? Because we
No,
have
no, we
an
are not.
identifier and we potentially have zero white spaces and this is an identifier.
No, no. In the way that we are describing, like right now, Z e-commercial REST is one identifier only. They are not two.
No. Yeah, but that's what I'm saying. We this description
Hmm.
allows both interpretations.
Really?
Yeah,
Okay, let me see.
we
Uh,
can parse with a convention. But that's a
Wait,
bit for
wait.
me to write.
Let's suppose we have a identifier, at least one. Then we consume a bunch of white spaces. Then we consume a bunch of white spaces until something that is not a white. Oh shoot! Wait. Oh ah. Oh okay. Maybe you're right. And we are parsing
No, but
diff.
we are taking a side. For me, that's fine. Because taking a side, we are removing ambiguity. And that's fine for me. The only thing that I want us to be is us to be aware that we are taking a side.
Hmm. Okay. What about the following? We interpret that as two separate ones, and we disallow to have e-commercial on variables.
That's the thing. That approach that you just described right now, I think that's just a speculation. I'm not entirely sure, but I
Mm.
think that's harder to do than the other one.
Really?
The
But
other
wait.
one is it's easier because you can allow everything to be part of an identifier.
No, no. Okay, okay. We are talking in two separate things, right? First of all, what the identifier allows or not. That's easy. Like, doesn't matter what we want. It's easier. But how we can parse the thing? Okay, Lemos. Let's go to the arguments and how the parser would do it, right? So
Yeah,
we have the left delimiter.
yeah,
Then we are consuming how many spaces we have it, right?
yeah.
Then we are checking, right? If fuck.
No, that
So,
would work. We would grab this until you find a white space.
no, take a look. If let's suppose e-commercial is a valid thing on identifier, right?
Yeah, that's fine.
And by the way, it can vary. It can be like, oh, it's not valid on the beginning, right? Let's assume it's valid everywhere.
Yeah,
So we will use alternatives, right?
yeah.
And how are the order? Is identifier first? Oh no, wait.
No, the alternative
No, it's
follows the
the
order.
many actually. Sorry, it's the many actually. It's
Yeah,
the many that we are going to use.
yeah. For this, you're gonna use many star
Yeah, but see,
identifier white space.
we use like many and identifier and some shit with white space, right?
Yeah.
So see, if we encounter a, a e-commercial, he will see that as identifier. Then he will consume the commercial as identifier, like as this first grouping. He will consume this on the first
No, I
grouping.
agree with you that using the current many star and identifier parsers, you're correct. But we could make a parser specifically for this.
What do you mean?
Yeah, we could make a parser that expects in the beginning this. We
Of
could.
course, you're not expecting to be this. But that's the thing. The variables already no, they already do that. That's the whole problem.
The variables are already doing that.
Yeah, if you're allowing like arbitrary things.
Wait, let me think about
Okay,
what you said.
write a lambda with only the variadic argument. Okay, so that the way it would parse that is the thing that we have right now. It would be only
This.
one. Yeah.
Yeah, but that's what I said. We can make a parser that will use alternative and we'll try this one first and then this one later. Because the
Oh.
order matters for alternative.
Mm.
So you're going to try to parse this first. If it fails, then you're going to try to parse this, which are the only options.
Mhm.
Then you may say, yeah, but how are you going to tackle this then? And then
Wait a bit.
my answer will be, I don't know.
Lemons. But that's the thing. The first. If we try to do the first one. Oh shoot! But your implementation with alternatives, it becomes really confusing. Because see, if you do that, we are still doing the many, right? So
No,
you
but the
have
many no, but the many is fine. The many will work with the alternative just fine.
no. It's not regarding working. It's because if the first one that you got or anyone, it's the e-commercial on the alternative, then we need to check if that was the case. Then all and we still have things after. Then we should have a parsing error. Like, see,
Yeah, but that's not possible with the approach that I said, right?
I'm not sure if it's possible, but it's what would have to be done.
No, I agree. I'm not denying that. I'm just saying that the way that I said about using alternative with the e-commercial and in the other grouping, like using this first
First, right? Yeah.
and then this, it will work for the correct way and the wrong way, which is this.
Oh, okay. I see. I see. Yeah. So not what you want for sure.
Oh no, wait. Just a sec. Oh yeah, this is optional. Yeah, so it would work both ways. Yeah, the correct way and the wrong one. I think we're gonna have to make a parser considering this, man. It's
Man,
gonna have to be a grouping of this.
like, no, please. But hey, list. How can I say that? Listen to me. Listen. I don't know, but hey, check. Listen to that. What about the following? Uh, First of all, we disallow e-commercial, right? On variables. We could disallow only as the first one, but if you are doing that, I think it's already worth discard entirely, right?
Wait, can you repeat? My mind was thinking about something else again.
So okay. What do you think about the following? We disallow e-commercial on the identifier parser, and that's easy. Don't need to worry about that. Okay,
Yeah, we can do that.
and with that, we are going to use like how can I? Okay, if you do like X e-commercial rest, right? Then those would be valid, and they would be separate things. And then you can argue, oh, but why are those not space separated as the other ones? Then we can argue, oh, the others are space separated because you need them to. Otherwise, there are one. But in this case, we don't need. Yeah, it's okay.
Yeah, I'm pretty okay with removing the symbol from a valid identifier. That's fine.
So let me see. Does that already solves our stuff? Let's go again. Life delimiter, arbitrary white spaces before. Then we have identifier with the optional white
Yeah, this
space.
would fail, I guess.
No, that would not fail.
Oh, no,
That
no.
would pass
Oh,
correctly.
sorry. This would parse correctly. That's fine. This
Uh-huh.
would also parse correctly.
Yeah.
This would parse correctly.
Yeah.
And
So,
this would
yeah.
also parse
Awesome.
correctly. Yeah, we're gonna have to create a special parser for this guy.
What do you mean?
Yeah, because we don't have a parser right now that does this behavior, like expects in the beginning this symbol and whatever is
Isn't
before
that just a
spaces.
prefix?
We don't have the prefix, right? This is the only parser that Zosint
Oh,
had that we don't have.
okay. But well, even if you do, like, that's really simple, isn't it?
Yeah, it's really simple to do.
So let me see. The parser would look at the first thing. The first thing, if it's an e-commercial, well, then you already know, like,
Yeah, I already know it.
okay. Then he would expect like white spaces and right delimiter, not identifier. Well, yeah, I think you should call it the the thing like done. We see if have any problems when implementing. But I think that does the job.
Yeah, okay. So
Wait, we
now,
have everything, right?
not everything.
No, I mean condition. No, look at the expression. We have all of those,
Actually,
and
this is the one we already have this one. We
we
already have
just
this one.
yeah we just delete that.
No, what do you mean?
We don't need that.
No, we do.
What is that?
This is an S expression. It's an expression surrounded by delimiters.
Yeah, what are you passing with that?
The first example.
The first example, show me that. Okay, this is an application lens.
Is this the one that you said that you're gonna have redundancy at some point?
Yeah, the application already deals with that.
Okay, so we're gonna discard the S expression concept. I don't know if we should do that, but okay.
Well, we could call application X expression, but it
Now
would be
that would be
wrong.
very, very bad.
Yeah. So I
Okay,
think we are
so
done. I think-
now we have a manual on how to parse stuff.
Yeah, and man, that took a time. Like, took
That
a
took
time.
2 hours.
Yeah, but maybe you agree with me that it was worth it.
It was
Yeah,
totally worth it, yeah. And making
right?
the meta language was also pretty cool.
You can say that.
Yeah, I love it. Yeah, I really like it.
Sure. Let me see. Do we stop here or do you want to parse something?
I think well, I want to go further because, well, I do like this subject. So I do want to go further.
So okay, but we need a closed scope so we don't, right?
Um. Okay, so
What
something
do
that we
you
can
want to
do is to
talk?
rename stuff.
No, come on, man. If you want to be here, we have to do something fun, like parsing new stuff. Oh, but
Application.
you mean just like that, right? Not like parsing.
Uh, Delimiters, and then you're gonna have an expression, um, which is wait a sec. Uh, get no, this is wrong. You can just call parser header. Yeah. Wait, the parser header is already counting the input. Yeah, it's already counting. Yeah. So you can just remove this, and that's it, right? What do you think? Oh no, we're
Uh,
missing the white spaces.
hey, but I'm thinking, man, like if we discard the condition, maybe you can even like do identifier, abstraction, application, like in one go. I'm
No,
not sure.
identifier we already have that. We just have to exclude the special symbol.
No, yeah, yeah. No,
The
be right back. Just
yeah, no, that's fine. Mm. think it's gonna be an app. In here, we want. Oh, and we're also gonna have to have the mini star. Yeah, that sucks. Space. Then just ignore it. Then the expression. Then here again, app. Ooh, wait. No, this is a grouping. Okay, so here I'm gonna have many. And here, just write space star. Left delimiter.
I'm back. Lemus,
Spaces.
let me. You're recording yet, right?
Yeah, I am still recording.
Yeah, I think that is no problem. Like, let me ask you something that might sound a bit weird and maybe too specific.
No, here it
But
comes. Space.
when you started working with me, do you remember how was my hair?
Yeah,
How was the...
pretty long.
Really?
Yeah.
When did you started working with me,
No,
man?
no, wait. I think I'm confusing your photo with yourself.
Oh yeah, probably.
No, it was fine. Like, nothing too crazy. Why?
No, not regarding being crazy or not. I mean size.
Yeah, that was pretty normal, like not long, I would say.
Do you
Maybe
know
I'm
what
remembering
month?
it wrong.
But do you remember what month was it?
No.
No.
Oh, January.
Really? January?
Yeah, I started at January there.
Oh, then I probably had a short hair, like,
Yeah.
right?
That's what I said. Normal, like not too
Oh.
long.
Oh. Yeah, like when I entered data risk, I went bald, like literally
Yeah,
on.
yeah, yeah, yeah. That your photo in their website, I think it's still that, by the way.
Really?
Yeah.
uh, yeah, so I went bald again, man.
No, yeah. Why?
Just, I don't know. We can talk about that
I
later.
don't know. Okay.
Okay, so
White
uh,
space. Ooh.
what do you think about starting by the identifier? Because even though we can write the other ones without that, uh, we cannot really test stuff if, like the arguments, if that's not working properly yet, right?
Yeah. White space. And this. Yeah. Okay, so this would be application. Do you agree? We don't have all of
Uh,
those yet, but
oh, supposing we have the many parser and such, right?
the many star and the white space star.
Okay, so
And the expression.
so let me see. Yo, Maget.
Exactly. Hello.
Okay, instead of doing this, let's just explain to Mageto what we did, and let's finish for today.
Ah,
Ethan.
yeah, that's fair.
Okay, so we did this today, Mageto.
Let's see. Mm, okay, booleans, limiting parameters. The what are the types we have, right? Right.
Yeah, no, aside from the types. We're not discussing types at
Mhm.
the moment, but that's fine.
Identifiers.
Sorry, just one thing. It's not arguments, it's
Function.
parameters. Magata even just said it.
Oh yeah, for me that's fine.
Is
Here.
okay. Okay, that doesn't look bad. Okay. Yeah, looks alright.
Yeah, so we spent that whole 2 hours doing
Why
this.
didn't you make this grammar in S expressions though? That's what Lisp is for.
That would be.
You are fucking kidding with us.
No, no, seriously. I mean, the Lisp was defined in Lisp, like the first version on the paper. It's defined in S expressions.
Yeah, no, I can totally believe that, but that
That's
would be
funny.
very, very
But
hard to
just
read.
being picky. But yeah, that's fine. And well, the white spaces you could only consider those. Like, did
Yeah,
you try considering like more like Windows things and
you were the one that said no windows, right? But
yeah, but I mean, if we can make it work, then that's fine.
uh,
I think there is like C as well for Mac, carry return, something like this.
Magita, but that is basically like a scaffold in the sense that you could do whatever white spaces. We haven't really settled on many things. Like
Yeah,
they are
yeah.
just there because we can pass already.
Hmm. Yeah, the grammar seems fine.
yeah, so this is good because now we have a
So
roadmap, like a guide to make the parsers.
yeah, but what did you guys finish like doing parsing really?
Um, Boolean expressions and arithmetic expressions. Yeah.
Dude, I would prefer the booleans to be like capital letter, man. Like something like scheme.
Yeah.
Uh, like remember how scheme handles that? Not I think it was hashtag T hashtag false, right?
I think that also, but maybe they are assigned to like variables also.
Yeah.
Not sure though.
I
Yeah,
would
but I think
just.
well, I'm just thinking like putting a hashtag in the beginning. That's not cool for this case.
Okay.
Yeah, but anyway,
Let's.
let's see.
I would just show to you, Maget, something that I did. I think yesterday, if I remember. Um, that's pretty easy to demonstrate. So you do this.
It's actually pretty nice to read it. I was expecting it would be way worse.
Magita,
Hmm?
I don't think we have to define it in any way. Why don't we call it just a variable and it's already started on
Oh
the
yeah,
environment?
Uh,
yeah. Bool true is one, right? And then everything equals to one. That's true, right, Nathan?
No, no. Well, I think you got me, but
Yeah, I did. Man.
just. I just want to demonstrate. I don't want exactly
But
to.
but here's the thing: like, if you're starting that as a variable,
Wait.
okay, because you have the type and the variable, right?
Yeah.
Is that what you're saying?
no, no. What I mean
Here.
is, uh, like, doesn't matter how you choose the what's the name, how you choose the casing. Like, you can do any casing. What you are doing is basically adding a keyword, right? So
Yeah.
suppose the true has the same format as either a identifier or a type. Like it's uppercase,
Yeah,
lowercase,
but
doesn't matter.
yeah,
The
but
way we distinguish is
what I'm thinking is that's different than, for example, a function identifier. For example, like end. That's different because that's
not,
not a type.
well, not getting it.
We
Like
can.
you can only assign that as a variable if it is like I don't know a function, native function or something like this.
No, that's not the case.
Why not?
Wow, we insert a variable in the thing. It's
You're
basically
gonna
inserted
insert
on
a
the
variable
math.
for what, man?
Well, for true.
Yeah, but what is true?
Well, true, it's true, or a yes then no. Like that's the value of it. And what is the type? Well, type boolean.
Dude, I don't like this, man.
Okay, what I'm saying is the way you want to add is basically adding a keyword, right?
I Yeah, that's a keyword that already has, because dude, that thing already that's a value, right? That represents the type itself. So bool, like
But what do you
mm,
mean by bool? Are we talking about true and false or about the type bool?
no, we're talking about the value bool.
Okay, true and false,
The
right?
value that represents like bool, right?
Okay. So basically, let's suppose the first case.
Oh, I see what you mean. I see what you mean. So okay, so it's not messing with the type, right? You're just like adding a keyword as a variable, and that's fine. It's like a prelude or something like this.
Yeah, it's what we already have, right?
Yeah.
And that's
Okay.
the thing. It would not technically be a keyword, right? Just a normal variable that is already inserted.
Mm-hmm.
They use if the user wants to
Yeah, I was thinking about
overwrite
that.
it,
Like, if you want
that's
to
his
overwrite,
problem.
yeah, but that's the user is stupid.
Well, um, we can continue discussing this, but I just want to
Unless
show
we
you.
disable shadowing,
I get
like you can't
that.
do shadowing.
Although this will change now that we defined the grammar, I still think that this structure will remain the same. So I made the two parsers that like this will be the future application parser kind of. It's hard to explain if you
Vamos.
if you
Like you saw the grammar, right?
yeah
So arithmetic, Boolean expression, they are literally application.
yeah that's what I noticed doing this.
So, okay, so saw that was good to explain that because
No. When I was doing this, I already noticed that.
oh, okay, I see.
They are exactly the same. You just change a few things to have the
Yeah,
correct
and that's
atoms
the
at the end.
thing. You don't even need to specify the correct atoms or something like that. You don't even need. They are literally like transparent for us. We just care if it's an application. The way we know it, if it's a arithmetic expression, a Boolean expression, it's just but what are you applying on, and what you tell that it will be what is on the prelude, right?
Uh, in term like I don't know if you're talking about spoon, but in here what we're gonna do is basically try all of them. We're gonna put all of these small parsers and use alternative to identify. Oh, this one worked. So this means that we're gonna have to use integer when making the correct node.
Yeah, that's my point, man. You don't need those. Application, you literally parse all of them, correct?
I don't know what you mean, man, because this
Hmm.
application node is different using booleans than using integers.
No, it's literally not.
No, it's
Take a look on
literally
the
not
grammar.
not the equal, man. This is written boolean. The other ones will be written integer.
Yeah, do you know how does that works? It works because the arguments are expressions. And one of the possible expressions are literals. And we know how to parse them.
Oh, you're talking about beefing these guys up, then.
No. I'm saying they don't exist
Yeah.
because application already parse them.
No. I don't. We are talking about two different things again. So, what is the return of any number right now? Will return to you the rest of the input, a tag success, and a number. But what this should do is to already give us the entire thing, like this. Because
Oh,
right now I'm having to
yes.
reuse them in this way using these function calls and stuff like that, because I still don't know if this worked. If this worked, oh, that's fine, but I have to transform it later. Using application, using the literal parser, which is what you said, so you're going to have a def fun literal here.
Actually, that's not exactly what I said. What I said is we are going to use the expression parser. It
Yeah, but
happens that one of the
the
possible
expression parser
expressions.
does not answer my question, because the expression
Oh,
parser has a bunch of alternatives.
yeah, one of those are literals.
Yeah, and the literal parser has also a bunch of alternatives, which is true
Yeah.
at the moment.
Uh, wait. It depends, but yes, you could write that way. You
No,
could
it's not
write one.
right that way. We have written that way. The literal has only two options.
No, yeah, indeed. But what I mean is, putting like the options there or inside only one thing called literal, like whatever, it's the same, I guess.
No. It's not the same, man. Because like the way that we have this, we are obligated to have a literal parser.
No, we are not. Like, man, take a
Then I
look.
don't understand. Then for
Take a
me,
look
this is
on
what
where
is
you are
written here.
using. Yeah, take a look on where you are using literal.
Here.
Right? You could literally copy and paste the content of your definition line there.
No,
That's what
no.
I mean, right?
Yeah, but
The
you can do
parser
that
doesn't
with
need to
everything.
reply.
You can have a monolithic one function for the entire code. That's one.
Yeah,
That's
but
not the
what I
point.
mean, yeah, but what I mean is, on the alternative of expression, you could have, oh, that's the Boolean parser, that's the number parser, instead of have a literal parser. But they are effectively the same, of
No.
course.
But that's
It will just be nested.
yeah. But that's
But
what I said. Though in the way that because if we want to do as you said, we just grab this and put it here. But it didn't do like that, right? So I'm saying like I'm gonna follow the grammar to make the parser, which means that in this case I'm gonna have to have a literal parser. I don't have an option.
yeah, you want, not that you need, but yes.
No, it's not about what I want. Again, is what I said. I will follow the grammar. That's a assumption to make the parser. I will
Yeah,
not.
I
I
see,
will
I
not
see, I
do
see what.
any hacking around this. I will follow this.
Okay, first of all, that's not hacking, but I see you are basically saying, oh, that's the grammar. I will try put one to one with my parsers, right? I'm just saying that's not necessarily the case, but sure, it could be the case for sure.
Yeah, no. I don't know
But,
why you would not do that. Because then why just don't change your grammar then? If you're not gonna follow this, change it.
okay, because the
That's
grammar is supposed to describe like the syntax on how we want, but the parser is implementation, man. We can't change stuff. But let's just assume, like, let's do this way because well, it's a lot easier to understand, right? Because you have one-to-one mapping. But okay, we are talking about something else, right?
I still have a problem with what you said. So, you don't have to follow this. The implementation of the parser can be different. Well, yeah, it can.
No, I'm saying you need to parse exactly that in the sense of parsing the syntax it describes, but it doesn't need to be divided in the same pieces.
No, yeah, that's exactly my point. So, if you want to do that, why just don't? Oh, don't want to have a literal parser. Let's just use an integer and a boolean. If you're gonna do that, why just not pick it here and remove it from here?
Man, because there are different levels of abstraction. I could might as well just I will describe my syntax in this way, but implementation wise, I would gain a lot for doing like something else.
So you gain
They
a lot about not
no no no
following
no no
strictly
no
one
no
by
no.
one.
I said you could.
No. Yeah,
Not sure that's the case.
I'm assuming the assumption. So you gain something out of that.
Yeah,
I'm
sure.
trying to
Like
think about what are those
okay,
cases.
abstraction, right? So let me see a particular case if I can think of one. Okay, I do know a particular case. So, for instance, you see the way we are describing stuff, like with many and stuff.
Yeah.
I could argue that a better way to describe that would be with recursion. And, well, that's a way to do it, right? But implementation wise, I could just use the implementation of many, like using a for loop and stuff.
That sounds a little bit off. I'm not. I want a more concrete gain of not following the thing. Because
Like one.
okay, so the grammar is describing to use recursion, and you're using a for loop instead of recursion. Yeah, but
No,
the
it's
point
not
is that
only.
the point that you're trying to leverage is that we we are gaining something out of not following, and I don't consider using a for loop instead of the recursion a gain.
Okay. It is a gain in the sense that let's suppose you are doing a language that doesn't have tail call recursion. Then it's a gain because it's the only way you can like parse a ginormous input.
Yeah, okay, that's a fair. Not all languages have theoretical
But man,
recursion.
I think we should skip that because like we can just do the one-to-one mapping.
Yeah, I'm still having a hard time trying to understand why you not want that. But anyway,
No, I didn't say I didn't want that.
No.
I'm
I
just
didn't say you
saying.
didn't want that. I'm saying, okay, you can do different than a one
Oh
by one.
yeah.
Why would you do that? And then
Oh
the
yeah.
answer for that is, oh, maybe you can gain something out of it. And then you said, okay, we don't have tail call recursion. How are you going to tackle that? And okay, if you don't have tail call recursion, why? Oh well, the answer for that
I
question would
said it
be
right. It's easier to.
no,
Okay,
not even
maybe I prefer
easier,
true.
right? Because we're not describing the grammar of the language you're using. We're describing the grammar of the language you're implementing. And maybe in your language makes sense to have recursion as the expression of the thing. But in the language that you're using to implement that, it doesn't have tail call recursion.
Oh,
Yeah,
okay, I
yeah.
see.
In this particular case, yeah.
But
Okay.
let's like after that, what we were talking about.
I was talking about that
The
this.
applic. Oh, okay,
Yeah.
those ones,
Yeah,
right?
so the
Arithmetic
literal
and Boolean.
parser will have two possible alternatives, which would be the any number and any boolean, just for an example here. And these
Mm-hmm.
guys will already create this.
Okay.
That's my understanding. And if that's the case, we don't need any of this because this was being used to create these structures.
Yeah.
And
Yeah. Then they had like really wrong names. Then they are not arithmetic and Boolean.
wait.
You were using those to create either literals of integers or literal of booleans?
No, I'm using this to make I was using these to
Oh,
make
okay, to make
this.
these and more, right? Oh,
Because I remember last session you said, oh, parsing an arithmetic and a Boolean expression is the same thing. And then
wait, parsing what?
parsing an um, arithmetic expression like a plus
Mm-hmm.
and multiplication stuff is the same thing as parsing a Boolean. You just
Wait,
change.
no, I think I said it application.
Yeah, no, you said they are the same because both are applications.
Yeah, in the sense, yes.
Yeah,
But
and
in
then
Lisp, of course.
I said, yeah, that makes sense. But how you gonna make that reusable? Like, how are you gonna? Okay,
Mhm.
there is some part of arithmetic and booleans there which is the same, but there are some parts where they are different. And then, oh, the parts that are different is basically only this and the translation, right? Because oh, we're gonna have a capital T as the symbol for true, but in our
Okay,
AST we're gonna have true here, like this.
I think you focus on that because you were looking too much at the implementation, man. Uh,
Well,
because
yes, I want
take
to
a look.
reuse stuff. Yeah, it is
No,
implementation related.
yeah, but I mean, if you pay attention on how I said it specifically, it already tells you how it does that. It does that in the sense that application. It's a bunch of expressions,
No.
right?
That's
And
the thing. That's the thing which is I would say it's not true, because
mm,
before this session of today where we made the grammar, that was not clear to me because our parsers are not correct. This is not correct.
and because they names on our AST they indicate otherwise, right? For you.
Yeah, our AST is like, oh, a tuple with a literal, and the second memory is also a tuple with the type and a
No, I
value.
mean the names there, like in abstraction, right?
Well, the names also didn't help, but my point is not that. My point is
Mm.
specifically that, oh, we have a parser that can parse a number, but the result of
Mhm.
this parser is not the node this. Oh, how can I make that happen? And then I made all these true yesterday, I think. But now for me, it's clear after making the grammar. Now it's clear to me that these guys need to already throw this to me.
Mhm.
And if that's the case, now it makes sense they are exactly equal as an application. Because
Yes.
you just don't care. The inner parser will do everything for you. You don't have to map it, because that is what I was doing. I was using parser map to correct these parsers. To oh,
Mhm.
you parse a number for me, but I don't want exactly a number. I want a tuple with a literal and an integer atom.
But can you think about which problem that would cause, like that approach?
It's hard to say. I only did two of these, but I
Okay.
would say that the way that we are gonna be doing now with application being like the parsers themselves, like this is already correct. I think it's gonna be easier to write, easier to understand, because this would require a bunch of repetition, I would say.
My question is, how many more would you have to implement?
That yeah, Exactly. I would have to implement one of these and one of these, like one of these auxiliary stuff, for each one of these parsers. And we have only two here, but we can have like I don't know how many more.
Okay, the other thing is, how would you parse something like that?
A plus, an A, and a B, and a 1. Uh, no, in this case I wouldn't. In this case I just
You
wouldn't.
wouldn't, right?
Because this is expecting numbers, the arithmetic expression. And
They
you're
are
declaring
like,
variables. So,
well, I mean, you could write one for this, right?
yeah, I could write one for that.
Yeah, they are always homogeneous there.
Yeah, exactly. So having this way, having the grammar first helped me understand how the application will handle like this by
Mm.
yourself by itself instead of us doing it manually.
Yeah, just one note. If we are using a language with types, you would have noted that soon because the types are exactly that. They say exactly that. That they are like arbitrary expressions everywhere, not a specific kind.
hmm Well, to be fair, this was just an experiment, right? We this was just kind of like a playground because I think we were kind of got excited about we can parse stuff now. We have the
And we
applicants.
didn't knew if it was really working.
Well, yeah, that's true. We didn't know if it was as powerful as we need. So, uh, but yeah, I'm pretty confident. We don't have all the parsers that we need, like the basic units. We still have we need to make the 0 or more one. Yeah, but that's a task for another day. I'll finish recording now.